Hello viewers, this is Walgadaro now taking you through the story of A-level pure mathematics. And this video I'm going to go through the marking guide of beginning of term 3 exam of one of the school where I happen to be a teacher. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So question 1 said that solve the simultaneous equations. So these are the two simultaneous equations and they want you to solve. So they didn't specify any method, so it is you to choose. You can use substitution, elimination, or other methods, but other methods are a little complex. So you can choose either substitution or elimination method. Now when I start from equation 2 and I make y the subject, I'll come up with y equal to 6 minus x. Therefore, come and substitute this y where there is y in the first equation to come up with this. So where there is y, I've substituted it with 6 minus x. Then when I open brackets, I'll come up with that. Open brackets further, I'll come up with that. Then after that, I will simplify. When I simplify, I'll come up with that because 2 plus 5 is 7, 7 plus 2 is 9, that is why there is 9x squared there. Then also negative 30 minus 24 is negative 54, that's why there is negative 54x there. Then the 72 is that. Now this is a quadratic and I can reduce to come up with that. Therefore I factorize to come up with that, and the values of x will be 2 and 4. But you also have to get the values of y. So when x is equal to 2, y is that, and when x is equal to 4, y is that. So basically that's what they wanted in this question. So M1 for this substitution, M1 for opening brackets, M1 for the quadratic equation, A1 for both values of x, and A1 for both values of y. So that was question 1. Now we shall go to question 2. Question 2 says find the gradient of the curve, this curve, at the point 0, 1. So this is an implicit function. You have to remember how to differentiate implicit function. So what we are going to do, we are going to differentiate both sides with respect to x. So when I differentiate x squared, I'll come up with 2x. Then when I differentiate xy, I'll come up with y plus x dy dx. Then when I differentiate 2y squared, I'll come up with 4y dy dx. When I differentiate negative 2, I'll come up with 0. So at this point, I'm going to substitute for x and y because x is 0 and y is 1. So when I substitute, I'll come up with that and make the y dx the subject to be that. Therefore the gradient they wanted is negative a quarter. So m1 for this derivative, m1 for this derivative, m1 for this derivative, equating it to 0. Then m1 for this substitution, a1 for the gradient. So that was question 2. Now we shall go to question 3, which says that solve the equation this. So the first thing to do is to make all of them under the same base. So this base 25 will be changed to base 5 by saying log base 5 of 4x squared, then over divided by log base 5 of 25. Then next I remember that 25 is equal to 5 squared, so that becomes 2 log base 5 of 5. Then after that I realize that these 2 can cancel and this one is equal to 1, therefore I remain with this here and this there. After that I realize that all of them have the same base, therefore this can cancel with that to come up with that. Then I realize that this is the quadratic, so let me rearrange it to form a quadratic, and after that I can either factorize or use bulldozer method to come up with two values of x, which is negative 3 and 1. Now these two values, you realize that when I put negative 3 here, it will become negative 3 squared, which is 9, and 3 minus 9 gives you a negative value, which is impossible. Therefore, you come and say that this x cannot be equal to negative 3, implying that x is equal to 1. So basically that is what they wanted. M1 for changing the base, M1 for eliminating the logarithm, M1 for solving the quadratic, that is factorizing or bulldozer, B1 for both values of x, and A1 for conclusion. That was question 3. Now we shall go to question 4, which says that given the points O, which is 0, 0, and P, which is 4, 2, A is the locus of the point such that OA to AP is equal to 1 to 2. Q is the midpoint of AP. Find the locus of Q in its simplest form. So you come and start from the given ratio. So let x be a variable point small x small y, and Q be a variable point capital X capital Y. That means that since Q is the midpoint of AP, it implies that this coordinate is got by getting the average. So average of this point and this point, x coordinate will be x plus 4 over 2, implying that when I make x small x a subject, it will be 2x minus 4. Then also average of this y coordinate will be this plus this over 2 to come up with this. When I make small y the subject, it will be 2y minus 2. So under loci, we are case sensitive. But we are given this ratio. This ratio means that OA over P is equal to 1 over 2. That is what we are writing here. Then when we cross multiply, we shall come up with 2OA is equal to AP. Now before we go to the next slide, let's see marks for this slide. So B1 for these two expressions. Then next we are going to substitute for OA and OP. So distance OA is this square root, this is the formula for getting length between 2 points, and AP is that. But remember there was a 2 here. Now next is to square both sides. So you can square both sides, but remember that small x is equal to this and small y is equal to this. So I'm going to substitute for this and for this and for this and for that. So when I do that, I'll come up with this. When I simplify, this side I'll come up with this, and this side when I expand I'll come up with this. Then when I square both sides, this 2 becomes 4, and when I expand this part, it becomes that. So next is to expand further, bring this 4 inside the bracket to come up with this. Then from there, we have to collect like terms. So collecting like terms, we realize that this one, for x squared, there is this, and there is also this. So when this one goes this side, it becomes 16 minus 4 to come up with 12. What about y squared? Y squared, there is this and there is also this. So when this one goes this side, it becomes 12. Then for x, there is negative 64 here, and there is also negative 32 there. So when this one goes this side, it becomes negative 32. For y, there is negative 32 here and negative 16 here. So when this one goes this side, it becomes negative 16. I can reduce this expression to come up with this, and basically that's what they wanted. So M1 for the correct ratio and substitution, M1 for substituting for small y and small x, M1 for squaring both sides, A1 for the locus. So it can be given at this point or at this point. So that was question 4. Now we shall go to question 5, which says that solve this equation. So the first thing to do is to remember that this one is the same as this. We are rearranging the powers, 3 to the power x in brackets to the power 2. Then from there I will say let y be equal to 3 to the power x. Then I substitute, this becomes that, this becomes this, and this becomes that. Now this is a quadratic, and sum is negative 5 and product is 4. Therefore the factors are negative 4 and negative 1, implying that this is that. Therefore I can factorize to come up with that expression. That means that y is equal to a half or y is equal to 2. For y equal to a half, we will come up with, that means that 3 to the power x is equal to 0.5. When I introduce logarithms, I'll come up with negative 0.6309. For y equal to 2, it means that 3 to the power x is equal to 2. Introduce logarithms to come up with positive 0.6309. So basically, that is what they wanted. So M1 is for the quadratic, then another M1 is for this solving or using bulldozer or factorizing, B1 for these values of y, A1 for the first value of x, and A1 for the second value of y. So note that we have factorized, so this method is given for factorizing or using bulldozer. Some students choose a calculator, and so that from here they come to this. That means that you have got only 1 mark, and these other 4 marks will be ignored because you missed the part of factorizing. So that was question 5. Now we shall go to question 6, which says using small changes show that this is equal to that. So we are going to let y plus small change in y be the required value, and x plus small change in x be this value in bracket, then power 2 remains the same. Now this one, x plus small change in x will be equal to this. Now how do you know what to put here? How to know? You look at this. This is a fifth, so you'll get your calculator and start 1 to the power 5. What is it? 1 to the power 5 is 1, which can't work. What about 2 to the power 5? It is 32, which is very small. What about 3 to the power 5? It is 243, which is closer to this. What about 4 to the power 5? 4 to the power 5 is 1024. Now when you compare 243 and 1024, you realize that 243 is closer to this value. So that means that you write here 243 and ignore the rest. So that is where that 243 is coming from. So with that it means that x is 243 and small change in x is 1. That means that y will be a fifth of x, which is 3. Now we have got this value of y, but we don't know this value of small change in y yet, so that is what we are going to get. So to get it, you have to first differentiate. So get dy dx. Dy dx, I will differentiate this one to come up with this. After that, I'll substitute for x to come up with this 1 over 405. Then from there, I remember that from small changes, this small change in y is approximately equal to dy dx multiplied by small change in x. Why? Because small change in y over small change in x is approximately equal to dy dx. So when I make small change in y the subject, I'll come up with that expression. So I'm going to substitute for dy dx and for small change in x to come up with 1 over 405. Then next, I'll remember that the required answer, the whole of this, is equal to y plus small change in y. So I'm going to substitute for y and substitute for small change in y to come up with 3 whole number 1 over 405 as the answer, and basically that's what they wanted. So b1 for getting this y and small change in x, m1 for this derivative, and b1 for the output, b1 for this value of small change in y, b1 for the required proof. So that was question 6. Now we shall go to question 7. It says the region bounded by the curve y equal to that, and the x-axis from x equal to 0 to x equal to 2 is rotated about the x-axis. Calculate the volume of the solid of revolution. So now here the good thing is that they have given us the limits to use and the curve to integrate. So we are going to come and just quote the formula that volume is equal to pi integral of y squared dx from the lower limit up to the upper limit. So when I substitute for y here, I'll come up with that. Then for you to integrate, I have to first expand this. So when I expand, I'll come up with this. Then after expanding, I can now integrate, then substitute the limits. Start with the upper limit where there is x, put there 2 to come up with this bracket, and where there is x, put there 0 to come up with this 0. Then next is to use the calculator to come up with the answer, and the unit is cubic units. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for this definition, M1 for expanding, and M1 for integration, M1 for substituting limits, A1 for the output. So that was question 7. Now we shall go to question 8, which says that show that this is equal to that. So first of all, we shall start with them from the left hand side and prove that it's equal to this right hand side. Now left hand side, this is what was given. So we shall realize that, so the aim of this is to factor out some of the factorials. So if you look at this, 16 is common throughout, so it can be factored out. So this one, you don't tamper with it. But denominator, here we have 9, 10, 11. And this other part we have 7, 6, 5. Meaning that we have to express this one in terms of 5 factorial, and also this one in terms of 5 factorial, so that we can factor out 5 factorial. Then also express this one in terms of 9 factorial, which is already 9. Express this in terms of 9 factorial, and this one in terms of 9 factorial. So this is how we are going to do it. So how do we do that? This 9 factorial, you don't tamper with it. But this 7 factorial, we are going to tamper with it by saying it's the same as 7 times 6 times 5 factorial. So in that, you have expressed it in terms of 5 factorial. But this 10, you are going to tamper with it because we want it in terms of 9 factorial, so it will be 10 times 9 factorial. This 6, you are also going to tamper with it because we want it in terms of 5 factorial, so it will be 6 times 5 factorial. This 11, tamper with it, it will be 11 times 10 times 9 factorial. Now this one, we don't tamper with it because we want 5 factorial. Now after that, you realize that 9 factorial, 9 factorial, 9 factorial, and also 5 factorial, 5 factorial, 5 factorial, and also 16 factorial, 16 factorial, 16 factorial. So that means that those 3 factorials can be pulled out, factored out. When they are factored out, for the first part, you are going to this one, these are out, so you remain with 1 over 7 times 16, which is that. For this part, this is out, this is out, this is out, so you remain with 2 over 10 times 6. This part, this is out, this is out, this is out, so you remain with 1 over 11 times 10. The next is to get the LCM. LCM is 7 times 6 times 10 times 11, which is that. Now this LCM divided by this first part, let me first remove this. So this LCM divided by this first part, it means that this cancels, you remain with 10 and 11, which is that. Then also this LCM divided by this, it means that this goes and this goes, so you remain with 11 and 7, which is there. But there's also this 2, which is there. Then the whole of this LCM with this, it means that this goes away, you remain with 7 and 4, 7 and 6, which is there. Now from there, the next step is to realize that the whole of this bracket, the whole of this numerator here is equal to 306. This factorial is already there. Now this factorial is already there. Then also here, this and this gives you the whole of this. Now our aim is to get this one, so that means that this 306 will be split into 2 and to be 18 times 7. So if you get a calculator and you say 18 times 17, you realize that you get 306. Then also the whole of this is the same as 11 factorial. I think you remember that from here. Then also the whole of this is the same as 7 factorial. I think you remember that from here. Then the whole of this now is 18 factorial. This we already got, so basically that is what they wanted. So M1 for expanding, M1 for factorizing, M1 for combining to one quotient, M1 for simplifying, and A1 for the output. So that was question 8. Now we shall go to question 9, which is that differentiate from first principles x squared with respect to x. So let y be equal to x squared. It implies that when I increment each side by small change to become, this becomes y plus small change in y, and this becomes x plus small change in x, everything squared. The next is to expand open brackets to come up with this. Then from there I'll remember that y is equal to x squared, so this and this will cancel, and I remain with that. The next is to divide both sides by small change in x. When I divide this and this cancels to remain with 2x. This one small change in x cancels to remain with small change in x. Then from there I'll remember that in the limit as small change in x tends to 0, the whole of this small change in x becomes 0, therefore you come up with 2x. So this is the definition for dy dx. dy dx is expression for small change in x, y over small change in x in the limit as small change in x tends to 0. So basically that's what they wanted. So they wanted 4 marks, so M1 will be for expanding, M1 for simplifying, M1 for small change in y, small change in x, that is B1, and B1 for dy dx. So that was question 9. Now we shall go to question 10. So question 10 part A says a polynomial px is given by px equal to this, where qx is the quotient and ax plus b is the remainder. When px is divided by x minus 1, the remainder is 4, and when it is divided by x plus 2, the remainder is 1. Find the values of a and b. There is part A. Part B, Roman 1 says expand this up to the 4th term, and Roman 2 says use the first 2 terms of the expansion to find the value of this correct to 2 significant figures. So we shall start with part A. So part A, that is what we are given as px. Therefore when it's divided by x minus 1, it implies that p1 is equal to 0, because p1, when you substitute 1 here, you get 0, meaning that the whole of this becomes 0. That's why there is 0 here. And here it becomes a plus b, that's why there is a plus b here. But they told us that the remainder is that. Therefore when I simplify, I'll come up with a plus b equal to 4. Similarly, when I divide by x plus 2, I'll come up with the second equation, which is this. Now when I solve those two equations simultaneously, I'll come up with a equal to 1, and when I substitute for a in the first equation, I'll come up with b equal to 3. So basically that's what they wanted. Now b1 for equation 1, b1 for equation 2, m1 for this solving subtraction, and a1 for the output value of a, and a1 for the value of b. So now we shall go to part B. So part B says that Roman 1, expand 1 plus x power 4 raised to the power negative 2 up to the 4th term. So binomial expansion, the formula is available in your mathematical logbooks. So that is the expansion. How is it done? So this one is put here, then after that you look at this power, you put it here, then look at also this term, put it there, raise to the power 1, then that is the second term. Now the third term, get this very power, write it here, then after that, that very power multiplied by that very power, but you subtract 1 from it. So this here, it was negative a half, here to be negative a half minus 1. Then after that, look at this term. You write it here. By this time it is squared. Here it was power 1 over 1 factorial. Here it will be power 2 over 2 factorial. That is the third term. What about the fourth term? Fourth term, write this again, which is this. Then the third one, the third term will be got by saying this minus 1, which gives you negative a half minus 2. Then also this very term, power is variables there. Here it was squared, now it will be cubed. But because it is cubed, you divide by 3 factorial. So that is the fourth term. They wanted the fourth term, so you remember to put these 3 dots to show that it is still continuing, but the question restricted us to only 4 terms. The next is to simplify to come up with. Now realize that we are using this symbol for approximation. Don't forget them. So the expansion will be 1 minus a half x power 4 plus 3 over 8 x power 8 minus 5 over 16 x power 12 plus dash dash dash. So that was Roman 1. So M1 for this, M1 for this, and M1 for this, B1 for simplifying. So now we shall go to Roman 2. Now Roman 2, they said use the first 2 terms, know that word, first 2 terms of the expansion to find the value of 1 over square root of 144.0144 correct to 2 significant figures. So this is the expansion we are going to use. We are going to use the first 2 terms, that is 1 minus a half x power 4. So you come here and realize that this one is expressing it in the given expansion, which is that. But remember, here we had 1 in our expansion. That means that you have to factorize out 144 to come up with this. Then you remember that this one raised to the power this is 1 over 12, and this with this can be reduced to become 1 over 10,000. So what does that mean? It means that when I compare, x power 4 is 1 over 10,000, therefore I'll come and use the expansion which was given. So this is equal to this. So that 1 over 12 is this, and this expansion is the one we got in the previous part, which was 1 minus a half x power 4. Therefore x power 4 is this, and a half is that, and 1 is there. So when I use a calculator, I'll come up with this, and when I use a calculator further, I'll come up with this. But remember, they wanted the answer to 2 significant figures, so we'll count 1, 2, and that will be the answer they wanted. So B1 for this expression, M1 for this substitution, A1 for the output to 2 significant figures. So that was question 10. Now we shall go to question 11. Question 11 says the diagram below shows a cone of radius A and height h, in which a cylinder of radius x is inscribed, as you can see it here. Part A, express the height h prime of the cylinder in terms of x, a, and h. Then part B, show that v prime is equal to 4 over 9v, where v prime is the greatest volume, note this word, greatest volume, of the cylinder that can be inscribed in the given cone of volume v. So first we have to express h prime in terms of a, in terms of x, a, h. There we are going to use something called similarity. So let's see how similarity is used. So similarity, we shall say that h prime over a minus x is equal to h over a. So how does it come about? So when you extract out 1/2, we shall be able to get something like a rectangle. So this is a rectangle with height h and base a. But also there is this other smaller right angle triangle also with height h prime and base from here to here, which is a minus x. So that is where the similarity is coming from those two triangles. Then when I cross multiply, I'll be able to get my h prime in terms of axh. Then for part B, we shall say that volume of the cylinder is given by pi r squared h. Now our r is x and our h is h prime. Therefore, when I substitute for h prime, I'll come up with that. Then I can factorize out, because this pi, this and this are constants. Now these are the variables, that's why they are inside. Therefore, I can now differentiate with respect to x. When I differentiate v1, I'll come up with this, because this is the constant, we leave it. Now differentiate ax squared, I'll come up with 2ax. Differentiate x cubed, I'll come up with 3x squared. Then for maximum volume, I know that the derivative is equal to 0. Therefore, I'm going to equate the whole of this to 0 and be able to come up with that. Therefore, x is equal to 0 or x is equal to 2a over 3. So before we go to the next slide, let's see how much can be awarded for this slide. So this m1 is for this similarity, and this one is for this right hand side. B1 for the required expression. M1 for substituting h prime into for h prime into volume. M1 for this differentiation. M1 for equating to 0. B1 for both values of x. Then when x is equal to 2a over 3, maximum volume will be equal to this. So from this formula, I can substitute for x, which is that. Where there is x, I put there this. When I simplify, I'll be able to come up with that, and therefore the maximum volume will be 4a squared pi h over 27. But the volume of the cone is equal to a third pi r squared h. So our r, radius of the cone, is a. Therefore, when I divide the two, remember they told us that the maximum volume is v prime. So this v prime is this, so which is there, and volume of the cone is this. So I divide. When I divide, you realize that this can become the, when this one changes to multiplication sign, this becomes the reciprocal. Then from there, I realize that pi can cancel, then also a squared can cancel, then also h can cancel, and also this 3 by this 27 gives you 9, which is here, and up we have remained with only 4, which is here. Then from there, I'll cross multiply and make v prime the subject to come up with the required proof. So basically, that is what they wanted. So M1 for substitution, A1 for the maximum volume of the cylinder, B1 for the volume of the cone, M1 for dividing the two, B1 for the required expression. So that was question 11. Now we shall go to question 12. So this question 12 says, part A, the first three terms of a GP are 4, 8, and 16. Determine the sum of the first 10 terms of the GP. Then part B, an arithmetic progression or AP has a common difference of 3. A common difference of 3. Then a GP has a common ratio of 2. A sequence is formed by subtracting the terms of the AP from the corresponding terms of the GP, meaning it is GP minus AP. The third term of the sequence is 4. The sixth term of the sequence is 79. Find the first term of the AP and of the GP. So just start with part A. Part A, we have these three terms of the GP, meaning that you can easily get the common ratio, which is 8/4 to give you 4, and also the first term is 4. So 8 divided by 4 is 2, meaning that the common ratio is 2. So you come here and say that first term is 4, common ratio is 2. Therefore, the sum of the first 10 terms, it means that n is 10, so we substitute and get 4092 as the answer. So that was part A. Now we shall go to part B. Now part B, we have AP and GP. AP has a common difference of 3, GP has a common ratio of 2. So they have given us the third term and the sixth term of the sequence. So we have to get the third term of the AP and GP, then also get the sixth term of the AP and GP, subtract the corresponding ones, and be able to get the sequence. The first terms of the AP and GP are the ones which are needed. So we shall come here, and it is easier to answer by tabulating. So what you are going to do, you are going to get the column of terms. We shall put first term, third term, and sixth term. So we shall start with the GP, because the sequence is got by saying GP minus AP. So GP, the first term is A1, second term will be AR squared, so the third term will be AR squared, but R is 2. So it gives you 4A1. Then sixth term is AR to power 5, which is 2 to power 5, so in the end you come up with 32A1. That is the GP. What about the AP? AP first term, let it be A2, third term will be A plus 2D, which is that. Then sixth term will be A plus 5D, which is that. Now the sequence will be got by subtracting. So this minus this gives me the first term of the sequence. This minus this gives me the second term of the sequence. This minus this gives me the third term of the sequence. So this is the first term, second term, and third term of the sequence. So before we go to the next slide, let's see how marks can be awarded for this slide. So B1 for identifying the first term, B1 for common ratio, M1 for substitution, A1 for the output. B1 for the first term of the sequence, B1 for the second term, B1 for the third term. So now we shall say that we are told that this term is equal to 4. Therefore, we shall be able to get the equation 1. Then we are also told that this term is equal to 79. Therefore, we shall be able to get the second equation. So those are two equations and two unknowns. Therefore, we have to solve them simultaneously. When I subtract 1 from 2, I'll be able to come up with 28A1 equal to 84, implying that A1 is 3. Then from equation 1, I'll realize that this substituting, when I substitute for A1, this A1 is 3, so put 3 here to come up with that. Therefore, remain with A2 as the only unknown, and in the end, A2 will be equal to 2. So now that we have got A1 and A2, we can now come and conclude that the first term of the AP is 2 and the first term of the GP is 3. So B1 for equation 1, B1 for equation 2, M1 for the subtraction, A1 for the first term of the AP. This is the first term of the GP, so this should be GP. Then M1 for this substitution, A1 for the output, which is the first term of the AP. So if you're a student in S5 or S6, I recommend these books that you get them and for further revision. So this is Mastering A-Level Paper 1. It contains all the notes of Paper 1. Then there is also Mastering A-Level Mathematics Paper 2, it contains all the notes of Paper 2. Then there is also this question bank, which has UNEP questions from 2020 up to 1988 with answers in it, compiled topic by topic. So those 3 books, I recommend them if you are an A-Level Math student. And if you are an A-Level Physics student, I recommend this book of Physics Paper 1 and also this one of Physics Paper 2. If you do some math, I recommend this. And if you know of anyone on O-Level, I recommend these books for O-Level. So for any of the copies of these books, you can contact the author on any of these 2 contacts. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on solutions for Math Paper 2 of beginning of term 3, still of the same school. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on marking guide for Math Paper 2 has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.